Alright, problem number 5. In the figure below, what is the ratio of the area of the shaded square compared to the area of the large square? So you might recognize these shapes. If you've ever played with tangrams, you'll recognize that these are just the classic tangram shapes. I'm actually going to show you a couple different ways to do this problem. One is just to assign a convenient dimension. Okay, so we aren't given any of the dimension, we're just asked to find a ratio. So it really doesn't matter what the dimensions are. Um, so let's just assign a convenient number like 1 to the side of this small square. Okay, so then we know that the area of the small square is what? It's just 1 square unit. Okay, I'll just say it's 1. Alright, so then given that, I'm actually going to scroll down and give this some more room. So given that, we know that this side is 1 and this side is 1 and so on. And so you can see here we have a 45, 45, 90 triangle, and we can use the Pythagorean theorem. So we know that the length of this side squared is equal to 1 squared plus 1 squared, right? So this side is equal to, so we could say c is equal to the square root of 2, okay? And by the same logic, this side here is also the square root of 2, which then means that the whole length of one side of the square is 2 times the square root of 2, okay? So this outer square has the dimensions of 2 times the square root of 2 by 2 times the square root of 2. So the area of the large square is what? It's just the dimension squared. So it's equal to 2 times the square root of 2 squared, which is equal to 8. Okay? And then the ratio is easy. The ratio is just 1 over 8. Alright? So 1/8 is the ratio of the small square to the large square. Okay? That's one way to do it. Another way to look at this too, again, if you've ever played with tangrams, you know that these shapes, you can take 2 triangles to form a square, and you can take 2 triangles here. If I were to draw a line, whoops, like I've said before, I have trouble drawing with this pen. Alright, so if I were to draw a line here, then we'd have essentially 1, 2, 3, 4 congruent triangles making up this larger triangle. And we could divide the square in half across there, and again we'd have 4 congruent triangles making up this large triangle. And these triangles over here could be divided in the same way, okay? We could just draw the smaller triangles in there. So essentially we're just breaking up the whole figure into congruent shapes. Okay, so each large triangle is made up of 4 congruent small triangles. And we have 4 large triangles, so 4 times 4 is 16. So we have 16 small triangles that we could break this thing up into. Alright, and they would all be the same size and shape. So, and then you can see that the small square is made up of 2 of them. Alright, so 2 out of 16 is the ratio of the small square to the large square, and that just reduces down to 1/8. Okay, so either way you get the same answer, whether you break the figure up into congruent shapes or whether you use the Pythagorean theorem and assign a convenient dimension. Doesn't matter. Either way you get the same answer, and the answer is 1/8. So there you go.